on this episode of Exploration Outer Space. For 60 years, we've been sending spacecraft to planet Mars.
Sojourner discovered evidence that Mars was probably much warmer and much wetter in its past.
I think a lot of people think of Mars as this dead red rock floating out in space. That is not the case at all.
Join us as we look at what we've discovered about Mars over the years. Hi, I'm Emily Calandrelli, and welcome to Exploration Outer Space. Today, we're looking at Mars and the important discoveries we've made over the years. And we'll start with the very first spacecraft ever sent there.
The Mariner program was a series of probes that NASA built at the Jet Propulsion Laboratory in the late 60s and early 70s. They were designed to visit all of the inner planets. A number of them were designed specifically for Mars, and they represented a number of firsts in Martian exploration.
In the 60s, NASA sends 3 Mariner spacecraft on flyby missions, taking photos that give us our first real look at Mars.
We had learned a great deal more about the Martian atmosphere than we knew beforehand, specifically temperatures within the Martian atmosphere, and of course, more detailed imaging of the Martian surface.
The Mariner program discovers that there is no magnetic field on Mars. This means that solar and cosmic radiation is raining down unimpeded. Before this mission, scientists thought that the air on Mars was mostly nitrogen and oxygen, just like here on Earth. But they discovered that it's primarily composed of carbon dioxide. And as far as the surface temperature, one of the instruments detects temperatures at minus 100 degrees Celsius. We soon come to the realization that Mars is a cold and lifeless planet. In the early 70s, NASA sends another spacecraft to Mars, but this one will continuously orbit the planet. Finally, we are able to observe the entire surface of this strange world.
We get much more close-up images of the surface than we'd ever had before. So you're starting to see the surface of Mars as a place where there's geography. You can see mountains, you can see gorges.
The images reveal riverbeds, craters, and gigantic but dead volcanoes, including Olympus Mons, the largest volcano in the solar system.
Yeah, Olympus Mons. So it's 3 times taller than Mount Everest, and the base of it is the size of about the entire state of Arizona.
Why is Olympus Mons so large? I ask that to my students in planetary atmospheres when we talk about Mars. I think it's for 2 main reasons. One is that Mars is a small planet. That seems the opposite from what you would expect, but small planets have less gravity, and that means that you can support a big structure like Olympus Mons. What goes right along with that is that Mars is cooler on the inside than the Earth is because it's a small planet, so its crust is thicker, and that helps it support the enormous weight of a big volcano like that.
Along with this intriguing landscape, questions arise. Is there still some form of life on Mars?
Even though Mariner appeared to show that there was no life on Mars, scientists still held out hope that there might be something there, and it was still worthy of scientific study.
Around this time, astronauts are exploring another celestial object, the Moon. While this dominates the headlines, Dr. Thomas O'Payne, the head of NASA, makes this statement. The true goal is far more than being the first to land men on the Moon. The real goal is to develop and demonstrate the capability for interplanetary travel. For this reason, further exploration of Mars is deemed necessary.
Interplanetary travel is going to be essential in the long term because eventually the Earth will become unlivable just due to solar evolution, never mind any other potential factors. And so these technologies that we're developing now will be important demonstrations that we can create a sustainable presence off Earth.
When we come back, the next step to understanding Mars is to put a spacecraft on the planet's surface.
Viking was designed to capture all kinds of geological data, meteorological data, and also look for life.
The next goal for discovering Mars is to put a lander on its surface. Accomplishing this feat is a daunting one, as the Soviet Union finds out firsthand.
The Soviet Union did send 2 landers to Mars in 1971, Mars 2 and Mars 3. Mars 2 did make it to Mars, did not survive its landing, failed on its descent. Mars 3 made it to Mars, made it to the surface of Mars, but the first image that it sent back was described as a completely gray background with no details, and then completely failed shortly thereafter. So ultimately, it was also unsuccessful.
In 1975, the United States gives it a try, launching 2 landers, Viking 1 and Viking 2. It takes 11 months for the landers to reach Mars, and remarkably, both descend to the surface safely, with the use of retro rockets.
Touchdown, we have touchdown.
Viking was designed to capture all kinds of geological data, meteorological data, and also look for life. It may not be big intelligent life, but there still might be different kinds of organisms on the planet. And this was also the first time that they knew that Mars was absolutely a solid planet.
Scientists hadn't been sure what the Martian surface would be like. It was possible that it was as soft as shaving cream, and the lander might sink.
And so the first photo that came back of Mars shows the leg of the lander so that you can see it's sitting on solid ground.
The 2 landers each contain instruments to study the weather.
And we discovered that there are traveling weather systems with cold fronts, warm fronts, just like we have in the mid-latitudes here on Earth. Near the equator, on a summer's day, temperatures can reach 70 degrees near the surface of Mars. But that same night, temperatures can plummet to over 100 degrees below zero.
They also have a scooper that gathers the Martian soil to inspect for signs of life.
So the lander ran various different experiments on it, heating it up, adding some liquid to it, to kind of see what would happen, what kind of gases and emissions there would be. Most of the experiments for life demonstrated no evidence for life, so none of the signatures came out.
Many in the science community are resigned that Mars is devoid of life. Yet, there is still so much more to be discovered. Data from the Viking mission indicates that there were massive amounts of water at one point in time. But since each lander remained in a single spot, that understanding is limited. If they could follow the water, perhaps it would lead to clues of past or even present life. What they need is a rover that can move about the surface. Despite the accomplishments of the Viking program, it will be 2 decades before another mission is sent to Mars.
The Viking missions were designed to explore Mars, to land on Mars, but also to look for life.
Now the question is, are Martian organisms the same on the inside as us?
Carl Sagan was part of that, the life detection experiments. And when Viking failed to find evidence for life, some people thought that Carl and others had jumped the gun, and so you couldn't really talk about looking for life on Mars for at least 15 years after that. I remember, because I was at NASA Ames, and we were just mum about it.
Another reason for the delay is simply the cost involved. The U.S. Congress is reluctant to commit a big investment to something that might not deliver a substantial return.
Planetary missions are always expensive, and if you look back at it and put the missions in terms of today's dollars, big missions like Viking are always on the order of $3 or $4 billion.
Coming up, NASA needs to find a cheaper way to send a spacecraft to Mars.
Basically what it boiled down to was fewer people, were going to be involved. Less redundancy and hopefully less red tape for everyone to cut through on their way.
After the Viking mission to Mars, the U.S. Congress no longer wanted to make such a large investment to explore what appeared to be a dead planet. NASA now had to come up with a less expensive method. That challenge would fall on the engineers at NASA's Jet Propulsion Laboratory.
NASA's Jet Propulsion Laboratory is really where it all happens when it comes to NASA's interplanetary and deep space missions. It's where missions that have been in design phases for decades finally come to life. They'll build the equipment there, they'll test it, launch it, and then control it from JPL and the Deep Space Network.
20 years after their last mission to Mars, NASA is finally ready to send another spacecraft for a mere $150 million.
And liftoff of the Delta rocket with Mars Pathfinder.
It's a lander called Pathfinder, along with a rover named Sojourner. After traveling through space for 7 months, they finally burst into the Martian atmosphere. Parachutes then slow them down as they approach the surface. Unlike the previous spacecraft they sent, this time NASA uses airbags to soften the landing.
The main thing that they accomplished, in my view, was to pioneer a new landing technology. So Viking had landed in the conventional way with retro rockets. It had to land in a very flat space or it would have tipped over. Pathfinder had airbags on it, and so it was capable of landing on one of the rockiest spots on Mars.
It was the first rover on Mars, so it was the first time that the spacecraft isn't just limited to sampling right where it landed. The rover can move around and can look at interesting rocks and can investigate its environment.
The first rock Sojourner probes is a 10-inch specimen called Barnacle Bill. The rock is loaded with quartz, indicating that it was heated and reheated multiple times. This suggests that Mars had been warm much longer than previously thought.
The rover took soil samples, adding a lot of evidence towards the idea that the rocks on Mars had been in a wetter environment in the past.
Pathfinder and Sojourner revealed that there was a period in the history of Mars when it was much more like the Earth than it is today.
Sojourner discovered evidence that Mars was probably much warmer and much wetter in its past. This was significant because we really did not understand what the early history of Mars was like. We didn't have enough information, and Sojourner, through its analysis of the soil and its analysis of the atmosphere, helped us to understand that there was a period in the history of Mars when it was much more like Earth than we see it today.
With the success of the Pathfinder Sojourner mission, on a shoestring budget no less, perhaps this will lead to more advanced rovers in the future. And one of the main goals would be to find evidence of life.
Well, when we think about searching for life, what we're really looking for, particularly in our solar system, is just microscopic life, just anything that's alive and reproducing. Because once we know that life started twice, once here on Earth and once somewhere else, then we know the universe is full of life.
In 2001, another spacecraft is sent to orbit Mars. Called the 2001 Mars Odyssey, it uses a spectrometer and a thermal imager to detect evidence of water. Scientists learned that at both poles there appears to be an abundance of water ice underneath the surface.
Mars has water in polar ice caps that are hundreds of feet thick. If we were able to melt that water into liquid, that water would be able to cover the surface of Mars to the depth of about 100 feet.
The 2001 Mars Odyssey also detects what appears to be deposits of water ice near the equator. Michael Meyer, a lead scientist of NASA's Mars exploration program, says, "The big surprise in the past 15 years of exploration is that the inventory of water on Mars is much greater than we had thought." Coming up, 2 more more rovers are sent to Mars and set out to confirm the extent of Mars's watery past. In 2003, NASA sends 2 more rovers to Mars. Named Spirit and Opportunity, these golf cart-sized rovers are armed with a spectrometer, which can analyze rocks and soil.
The primary goals of the Spirit and Opportunity rovers boiled down to determining the potential for life to exist on Mars in the present day, determining whether there's any recoverable water on the Martian surface at present, and determining when water may have existed on Mars in the past and how much may have existed.
Spirit's landing site was chosen to be Gusev Crater. It was thought to resemble things like our Grand Canyon on Earth, which was carved by ancient water flows. They thought that perhaps the Spirit rover would discover signs of an ancient water flow down into the crater. The choice of landing site for Opportunity, Meridiani Planum, was actually chosen on the basis of some observations from orbit by the Mars Global Surveyor, discovered signs of hematite minerals, which on Earth form in the presence of water.
These rovers make some fascinating discoveries.
The rovers did find examples of waterborne minerals around on the surface. They actually found these little tiny spherules, or little tiny balls of material that scientists were calling blueberries because that's how they appeared in the photographs.
It turns out these blueberries contain large amounts of hematite, a mineral that on Earth typically forms in water. The environment also proves to be just as telling as the minerals they find in the rocks.
One of them were these horizontally bedded rocks, these sedimentary layers that could have formed by water advancing and retreating in the same area for millions of years. So between the sedimentary layers and the hematite-containing spherules peppered all over the place, these suggested that this area on Mars, at least, was much warmer and wetter in the distant past.
In 2011, a car-sized rover named Curiosity is sent to Mars. It is the most sophisticated rover yet.
It has a number of laboratory instruments on board, so it can actually carry out experiments and analyze any samples that it brings on board.
The brain trust back at NASA's Jet Propulsion Laboratory determines which soil or rock samples they want Curiosity to examine.
The way we drive the rovers is we bundle up all of the set of instructions for what it's supposed to do for the entire day and send it up, and it executes it. And we call it rover driving, but rover driving includes operating the robotic arm and the sampling system.
Curiosity's drill sample findings were exciting in that they essentially found elements that are considered to be the building blocks of life. You had results such as hydrogen, phosphorus, sulfur, carbon, nitrogen.
The rover also identifies clay materials, similar to what you'd find in a freshwater lake. Curiosity chief scientist John Grotzinger declares, if this water was around and you had been on the planet, you would have been able to drink it. Curiosity also finds sulfates and chlorides, hallmarks of salty liquids. It's proposed that, at another point in time, this area had shallow, salty pools.
If you think about seawater on Earth, that salt was actually one of the first environments that life arose on Earth. And so you could really imagine a pretty hospitable environment for life, potentially.
Curiosity, along with the previous rovers, Spirit and Opportunity, achieved one of their main goals. They proved that Mars once had a habitable environment.
You can't even estimate how invaluable they've been. All of the things that we've managed to learn from Mars. They're some of the greatest explorers humanity's ever had.
The latest rover sent to Mars is Perseverance. Similar to the Curiosity rover, this one will also gather soil and rock samples. But what's unique is that these samples will be returned to Earth on a future mission for further study.
The history of the planet is written in its rocks and its soil. So if you look at a core sample and you step back through the core sample, it's like going back in time.
With each mission we send to Mars, we understand a bit more about this strange world.
I think a lot of people think of Mars as this dead red rock floating out in space. But the more missions that we've sent there over the last few decades, the more we're realizing that is not the case at all. Mars is a really dynamic place. It's got gigantic dust storms. It has seasonal changes in things like ice. It even snows in the atmosphere. It never hits the ground, but we've seen some snow. And so the more we look at Mars, the more complicated we're actually realizing that it is.
But for all the landers, rovers, and satellites we've sent to gather information, our greatest insights will occur when we're finally able to send humans, where they can gain firsthand knowledge.
Without a doubt, robots have helped us understand that we can look at Mars as being a much different place than we ever expected. But at some point, we'll need to send people to Mars so that we can pull together all kinds of little bits and pieces of information. And this is the beauty of having humans integrate on the spot to make an interpretation that might take years for us to come to if we're doing it remotely.
The fact that Mars has liquid water in some areas beneath the surface gives us hope that perhaps there's still microscopic life that exists. But even if we find out there is no life anywhere, by creating a human presence on this planet, we could become the life on Mars. I'm Emily Calandrelli, and we'll see you next time.